Over 66 million years ago, Earth experienced one of its most dramatic and transformative events: the extinction of the dinosaurs. Hidden below the waters of the Gulf of Mexico, the Chicxulub crater marks the impact site of an asteroid that struck Earth. The Chicxulub crater, which is estimated to be 200 kilometers (120 miles) in diameter and 1 kilometer in depth, is one of the largest impact structures ever found on Earth. The most consequential outcome of this cataclysmic event was the fifth mass extinction, which wiped out about 80% of all animal species, including the non-avian dinosaurs. This cataclysmic moment marked the end of an era and paved the way for the rise of mammals, and eventually, humans. But what exactly happened on that fateful day when the reign of the dinosaurs came to an abrupt end? The late Cretaceous period was a time teeming with jaw-dropping biodiversity and colossal creatures that dominated every corner of the planet. It was a world alive with constant change, continents on the move, ecosystems flourishing, and life evolving in spectacular ways. Back then, the continents were like drifting puzzle pieces, slowly wandering across the planet's surface. If you think the world today is hot, wait till you feel the insane temperatures of the late Cretaceous world. Scientists estimate that it was about 10 degrees Celsius warmer than the planet today, which might not sound like much. But when you're talking about a whole planet, it's a massive difference. Remember, this was a world with no polar ice caps at all, and high levels of carbon dioxide from tons of volcanic activity. Instead of ice, dense forests covered the poles where dinosaurs thrived even through the long, dark winters. The tropics were a steamy sauna, with ocean waters reaching a balmy 30 degrees Celsius, while the coldest polar winters barely dipped below 14 degrees Celsius. And ruling it all? The dinosaurs. These incredible creatures had evolved into a dazzling variety of shapes and sizes, each uniquely adapted to their world. In North America, the Tyrannosaurus rex, an absolute powerhouse of muscle and precision, stalked the plains. Its skull, nearly the size of a human, but packed with serrated teeth capable of crunching through the bones of a prey animal like it's nothing. But that doesn't mean its prey were defenseless. The Triceratops, for instance, were herds of three-horned giants that roamed the land with massive frills and sharp horns, ready to fend off even the most fearsome predators. Head south to the forests of South America, and the ground shudders under the steps of Argentinosaurus, a sauropod so massive it defies imagination. Stretching over 30 meters long and tipping the scales at 70 tons, this gentle giant was one of the largest creatures to ever walk the earth. The skies was the domain of the pterosaurs. These flying reptiles came in all shapes and sizes, from the sparrow-sized Anurognattus to Quetzalcoatlus, whose wingspan rivaled a small airplane. Some glided over the shallow seas, snatching fish with precision, while others stalked the land, hunting smaller prey. The oceans, on the other hand, were ruled by the sleek and speedy Mosasaurus, a total powerhouse of a predator that had double-hinged jaws and teeth that pointed backward, making it a nightmare for anything that got too close. And let's not forget the ichthyosaurs. These dolphin-like creatures were still hanging in there, even if they were on the decline. But the ocean wasn't just about the big players. It was buzzing with all sorts of smaller critters, too. There were ammonites, ancient relatives of squids, and tiny microorganisms like coccolithophores and foraminiferans, which helped create those iconic chalk beds we know from the Cretaceous period. Meanwhile, in the shadows of these giant dinosaurs, early mammals were quietly making their mark. They were adapting in some pretty clever ways. Take Repenomamus, for instance, a plucky, badger-sized predator with very sharp teeth. Unlike the tiny scurrying mammals we often imagine from this era, Repenomamus was bold and opportunistic. Fossil evidence even reveals its last meals were the tiny bones of juvenile dinosaurs found preserved in its stomach. And then there was Volaticotherium, a glider that zipped through the trees. Other mammals, like Docophosor, were digging burrows to hide from predators, while Aquatilivipes was splashing around in the water, hinting at the future where mammals would rule. These little furballs were warm-blooded and could nurse their young, laying the groundwork for the incredible evolutionary changes that were just around the corner. They were setting the stage for a world that would soon see them rise to dominance after the dinosaurs had their day. During the Cretaceous, evolution was in full swing, with life rapidly adapting to the ever-changing landscapes created by shifting continents, rising seas, and fluctuating climates. Some dinosaurs were massive, their thunderous footsteps shaking the ground beneath them. But that's only one part of the story. Dinosaurs weren't all giants. Some were feather-light and quick, others were towering giants, and a few were even as small as modern-day chickens. The diversity of these creatures is mind-blowing, and it's what made them so fascinating. They were divided into two main groups based on their hip structure, Saurischia and Ornithischia. These might sound like technical terms, but they represent two distinct ways of life that shaped the dinosaur world in very different ways. The Saurischians, or lizard-hipped dinosaurs, were a diverse bunch. They included everything from fierce carnivores, like the notorious Tyrannosaurus rex, to gentle giants like the Brachiosaurus. The theropods, like T-Rex, were the top predators, armed with razor-sharp teeth and powerful jaws built to tear flesh. But it wasn't just about the hunters. Herbivorous Saurischians, like Brachiosaurus, with its towering neck, were just as remarkable. They could reach treetops no other herbivore could, feeding on foliage far out of reach for others. For them, it wasn't about speed, it was about survival and endurance. On the other side, we have the Ornithischians, or bird-hipped dinosaurs, an equally fascinating group with a range of species, from the armored Ankylosaurus to the spiked Stegosaurus. These herbivores were built for defense, with bony plates, thick hides, and sharp spines to keep predators at bay. But it wasn't just their physical defenses that made them remarkable. The Cretaceous was a time of incredible diversity, not just in the creatures that roamed the Earth, but in how they lived. Far from the image of solitary giants, many dinosaurs thrived in tight-knit social groups, interacting and working together, whether they were fearsome carnivores or towering plant-eaters. Take the Hadrosaurus, for example, the duck-billed dinosaurs. These herbivores traveled in large, coordinated herds, moving across the land in search of food, much like modern-day elephants or bison. They were social animals, likely communicating with each other through calls and impressive crests. Imagine these massive herds moving across the plains, the ground trembling under their collective weight. Their strength was in their unity. Sticking together made it harder for predators to single them out. For the carnivores, social dynamics were just as fascinating. Take the velociraptor, for example. While movies often portray them as lone hunters, the reality was quite different. These clever creatures actually hunted in packs, using teamwork and strategy to bring down prey, more like wolves than the solitary assassins we've come to expect. Agile and intelligent, they relied on cooperation, with each member playing a role in the hunt. Their success didn't come from sheer power, but from their ability to outthink and outmaneuver their prey. Migration was another key part of dinosaur life. Although we can't say for sure, fossil evidence points to some species, especially herbivores, traveling long distances in search of food. 100 years ago, they were moving across vast landscapes in search of lush vegetation, much like the great migrations of wildebeests in Africa today. These dinosaurs would have followed seasonal patterns, adapting to the changing climate and landscape, always on the move to survive. These vibrant creatures thrived during the Cretaceous, creating a world teeming with life. It's incredible to think how different our planet would be if they had survived. But in the blink of an eye, everything changed. One moment, they were flourishing. The next, over 3/4 of them were gone, leaving behind only fossilized traces of a world that once was. It's a stark reminder of how fragile life can be, and how quickly everything can shift. On that day, 66 million years ago, nothing must have looked different or out of the ordinary. But if we could have watched them, we would have witnessed the rhythm of their world, their daily routines, their struggles, and their triumphs, just before everything came crashing to an end. Something massive, something from beyond the stars, is about to change everything. This wasn't a storm or a passing thundercloud. It was an asteroid, the size of Mount Everest, and it was hurtling toward Earth at a speed so fast it could melt the air around it. The asteroid had been drifting through space for millions of years, broken off from some larger chunk of rock in the asteroid belt. Until one day, by pure chance, it ended up on a collision course with Earth. As it got closer, it wasn't just falling. It was racing, faster than you can imagine, nearly 20 kilometers per second, gathering all that speed to unleash a world-shattering punch. Suddenly, a blinding light and a scorching fireball envelops them. It is the last thing these dinosaurs see. When the asteroid hit the upper atmosphere, things got wild. The Chicxulub impactor, as it is called, was somewhere between 10 and 15 kilometers in diameter. The collision was devastating. Rocks from deep within Earth's crust were raised 25 kilometers high, and a rim of mountains taller than the Himalayas formed around the crater's edge. The air pushed back with such force that temperatures soared to tens of thousands of degrees, hotter than the sun's surface. Dinosaurs, mid-step in their daily routine, must have paused, senses overwhelmed, their instincts kicking in, feeling the heat, and hearing a deafening roar that made everything tremble. This catastrophic moment took place near what we now know as the Yucatan Peninsula in Mexico. Scientists believe the asteroid struck at a shallow angle, maximizing the chaos it unleashed. In less than a second, the asteroid disintegrated, transferring its unimaginable kinetic energy into everything around it. The explosion was equivalent to 100 trillion tons of TNT. Imagine billions of nuclear bombs packed into one cosmic bullet. A fireball lit up the sky, visible from space, and temperatures soared hot enough to ignite the atmosphere. Anything in the immediate vicinity, be it living or not, was vaporized instantly. The impact created a crater over 150 kilometers wide, and shockwaves blasted outward with devastating force. The world had turned into a fight for survival, and no one knew if anything would ever be the same again. In the hours after the impact, the Earth's atmosphere became a violent mess. Roaring fires ignited everywhere, scorching forests and grasslands, while massive clouds of smoke and ash choked the air. For creatures fleeing the flames, the landscape was no better. No shelter, no food, just a barren wasteland. Rivers ran black with soot, carrying the remains of everything caught in the blaze. The world had turned into a fight for survival, and no one knew if anything would ever be the same again. One of the most telling pieces of evidence for this colossal event is the iridium-rich layer found in sedimentary rocks all over the world. Iridium is rare on Earth, but abundant in asteroids, and this thin layer serves as a fingerprint of the impact. It marks the boundary between the Cretaceous and Paleogene periods, a clear line separating the age of dinosaurs from everything that followed. Fossil records show a sudden drop in biodiversity above this layer. Around 75% of Earth's animals, including dinosaurs, suddenly died out at the same point in time, what we now call the KT mass extinction event. The immediate aftermath of the impact was nothing short of catastrophic. The ground shook with the force of magnitude 12 earthquakes, way beyond anything we ever see today. Landslides, liquefaction, and the collapse of entire regions followed in quick succession. The oceans responded in kind. Waves hundreds of meters high surged outward, swallowing coastlines and flooding ecosystems. For context, the deadly tsunami that hit Honshu in the 2011 created waves that rose only about 40 meters high. We've even found tsunami deposits from this disaster as far away as North Dakota, thousands of kilometers from where it hit, showing just how powerful those waves were. But that was just the beginning. Ejecta, chunks of molten and vaporized rock, were blasted into space before raining back down on Earth. These fiery projectiles superheated the atmosphere, sparking massive wildfires across the globe. Fossilized charcoal layers tell the story of these infernos that ravaged forests and grasslands, leaving behind a charred, smoldering landscape. The heat must have been unbearable. Temperatures in the atmosphere likely soared above the surface of the sun, incinerating everything in sight. After the asteroid hit, debris shot up into the atmosphere like a cosmic explosion, mixing with vaporized rock, sulfur, and ash. This stuff didn't just vanish. It formed a thick, suffocating dust cloud that wrapped around the entire planet. Within hours, the sky was choked out, and what had once been daylight was swallowed by an eerie twilight that quickly turned into total darkness. No sun, no light, just blackness. And with it came a brutal chill. Temperatures plummeted fast, and the warm, tropical world of the Cretaceous was now trapped in an impact winter. Plants, which had always soaked up sunlight, started to wither and die. The forests that once buzzed with life became ghostly, skeletal ruins. And this darkness? It didn't just disappear overnight. It stuck around for years, turning everything upside down. The temperature dropped fast and hard, especially in places used to heat. Tropical areas, normally sweltering, found themselves shivering in near-freezing conditions. The poles, which had no ice caps left to keep the cold at bay, became barren wastelands. The weather was absolutely wild. Storms raged, and chaotic winds howled across continents, blowing debris from the impact everywhere. With the sun gone and no photosynthesis to keep things alive, the food chain crumbled. Plants, the lifeblood of nearly every ecosystem, were dying off left and right. Forests, already scorched by wildfires from the impact, now faced freezing temperatures and endless darkness. The few that managed to survive the fire soon froze, their blackened remains standing like eerie sentinels to a lost world. The ocean in North America was lucky. It didn't die from fires and boulders falling from the sky, but a bit later, when a gigantic 100-meter tsunami rose from the ocean to get some idea about its scale. Nonetheless, almost the entire island state incurred losses. But the giant tsunami caused by the asteroid impact went thousands of kilometers deep into the land. It flooded almost the entire territory of the future USA. they didn't just make a splash. They wiped out entire marine ecosystems in seconds, dragging everything in their path back into the depths. Coral reefs, once bustling with color and life, were crushed or buried under tons of sediment. For marine reptiles like mosasaurs and plesiosaurs, survival became impossible. Some were swept away by the waves, while others had to face the long, slow torture of a poisoned, lightless ocean. Phytoplankton, the tiny plants that form the base of the entire marine food web, were the first to go, killed off by the lack of sunlight. With them gone, the ripple effect spread through the food chain. Herbivorous zooplankton, then the small fish that fed on them, and finally, the large predators like mosasaurs that relied on this fragile balance. As food sources vanished, these once mighty hunters found themselves in a fight they couldn't win. Fossil records show their sudden disappearance, a tragic end to creatures that once ruled the seas. But the devastation didn't stop there. Acid rain came pouring down, adding more destruction. When the asteroid hit, it vaporized sulfur-rich rocks, sending massive clouds of sulfur dioxide into the atmosphere. This mixed with water vapor to form sulfuric acid, which rained down on Earth, poisoning lakes, rivers, and soil. The acidified environment made it even harder for the few plants and animals hanging on to survive. For the survivors, the struggle to stay alive was a brutal, non-stop battle. Herbivorous dinosaurs, those giant plant eaters, were hit hardest. Without a steady food supply, their enormous bodies became more of a burden than a blessing. As the vegetation disappeared, their survival became a race against time, and they lost. Carnivores like Tyrannosaurus rex, once the undisputed kings of the food chain, were suddenly starving too. With no herbivores to hunt, many of them resorted to scavenging, picking at the remains of their plant-eating cousins before the hunger finally took them down too. Fossil evidence suggests it was a sad, desperate end for even the mightiest of predators. In this world falling apart, the little mammals had a surprisingly big advantage. Those small, furry creatures that had lived in the shadows of the dinosaurs for over 150 million years were built for tough times. Their small size and burrowing habits allowed them to hide from the worst of the chaos. With flexible diets, they could munch on seeds, insects, and whatever detritus was left behind as the world crumbled around them. These early mammals were like seeds of a new future, quietly waiting for their moment to rise and fill the void left by the dinosaurs' fall. Birds, those high-flying survivors, proved their mettle during this tough time. With their wings, they could scout out hidden pockets of food, and their diverse diets helped them adapt to the scarcity that followed the disaster. Some managed by scavenging, while others fed on seeds and small critters. Reptiles and amphibians, too, found ways to endure. Those that could enter brumation, a sort of reptilian hibernation, had the upper hand. By slowing their metabolisms and hiding in burrows or underwater, they could sleep through the worst of it. Crocodilians, for example, hunkered down in the warmer spots of rivers and swamps, waiting for better days. As months passed and turned into years, the darkness that had blanketed the Earth slowly started to lift. The ash and debris in the atmosphere cleared, letting the sunlight break through. But as the light returned, so did a new problem. A greenhouse effect caused by all the carbon dioxide spewed into the air. The planet became a hothouse, with temperatures soaring for thousands of years. The world that emerged was a shadow of its former self. The landscapes were scarred, ecosystems were simpler, and biodiversity had taken a serious hit. The extinction event that marked the end of the Cretaceous and the beginning of the Paleogene wasn't just a catastrophe. It was a turning point. The Chicxulub crater stands as a haunting reminder of that world-changing impact. It may have ended the reign of the dinosaurs, but it also opened the door for mammals. From the ashes of the Mesozoic, a new chapter in Earth's story was ready to begin. For thousands of years, Earth teetered on the edge of life and death. But then, just when it seemed like the planet was running on empty, something remarkable happened. The first green shoots appeared. Ferns and mosses, the world's first green rebels, started to push their way through the battered soil. They were like that one overachiever who thrives in a crisis, able to grow in the dim post-apocalyptic atmosphere with shallow roots that didn't need the deep, rich soils that once nourished towering forests. They helped hold the soil together, setting the stage for bigger, more complex plants to follow. As the ferns made their mark, they were soon joined by tougher, more resilient plants, cycads and conifers. These plants were built to last, with wax-coated leaves that could endure the scorched, semi-arid landscape left behind by the global fires and acid rains. With the plants making their grand return, the animal kingdom started to wake up too. And those who made it through the chaos, they had one thing in common: adaptability. Mammals were among the first to bounce back. Small, warm-blooded, and with a flexible diet, they had been quietly waiting in the wings for their chance. For millions of years, they'd lived in the shadows of dinosaurs, sneaking around as nocturnal foragers and burrowers. Now, with vegetation sparse, they were ready to take full advantage of the few insects and plants that had managed to survive the KPG event. The first rays of sunlight through the ashen sky, lighting up a world that would never be the same. In this new beginning, small mammals scurried through the underbrush, exploring a landscape dotted with early shrubs and trees. Some, like multituberculates, developed teeth perfect for gnawing on seeds and tough plants, setting the stage for the herbivorous mammals that would eventually rule. Others, perhaps more opportunistic, turned to insects, carrion, and even small prey. It was a time of rebirth, where every tiny change could mean survival. Birds, too, were spreading their wings, literally and figuratively. Using their ability to fly, they explored vast areas still recovering from the devastation. And some would even evolve into larger, flightless forms. Their feathers, a trait passed down from their dinosaur ancestors, helped them weather the harsh chill of the impact winter. It was the dawn of something new, a world in the making. The oceans were starting to heal, but it wasn't a quick fix. The process was more like a slow recovery after the devastation. But as phytoplankton, the tiny plant-like organisms that form the foundation of the marine food chain, began to make a comeback, marine life started to piece itself back together. Small fish and crustaceans were the first to come, thriving in the now clear waters that had once been ruled by massive predators. Over time, new marine hunters emerged to fill the gaps left by the mosasaurs and plesiosaurs. On land, the story was similar. Forests began to regrow, but they were different from what had stood there before. The flowering plants, or angiosperms, which had already been spreading during the Cretaceous, but now they stepped forward to claim their place. They produced seeds wrapped in fruit, which drew in insects and critters to help with pollination. This new method of reproduction kicked off an insect boom, which in turn made a tasty snack available for the growing number of herbivores. Early flowering plants like magnolias, which had evolved in the Cretaceous, spread quickly, taking over the landscapes left behind by the older, gymnosperm-dominated forests. They adapted swiftly to the cooler, temperate climates that followed the global chill, replacing the old with the new. It was a time of change. Life was finding its way in a world that was still finding its new rhythm. The rapid spread of angiosperms got a huge boost from the animals that came along to help with pollination and seed dispersal. Insects, which had somehow survived the initial chaos like beetles and flies. Their delicate bodies were perfect for picking up pollen and spreading it from flower to flower, sparking an explosion of plant diversity. Some insects even developed special feeding structures to sip nectar, while others took a more laid-back approach, munching on the fruits of these new plants. Meanwhile, those adaptable mammals that had survived the extinction event, now free from the constant danger of dinosaurs, experienced their own evolutionary boom. With fewer predators around, they had the space to evolve in ways that were impossible during the Mesozoic. Over the next few epochs, these small rodent-like mammals turned into a wide array of forms. Herbivores, with long legs and big bodies, agile predators, and even massive beasts like the ancestors of elephants and whales. The evolutionary arms race that had once been all about dinosaurs was now shifting to mammals, and they were ready to innovate in exciting new ways. New ecological niches popped up everywhere in the wake of the dinosaurs' extinction. Where a massive sauropod had once munched on treetops, early mammalian herbivores evolved long limbs and flexible necks to reach those same heights. Meanwhile, the swift theropods were replaced by carnivorous mammals that sharpened their senses and honed their speed to chase down prey. This burst of life, known as adaptive radiation, kicked off a new chapter for Earth. Evolution was on a roll, relentlessly and creatively filling in the gaps left by the asteroid. By the Paleocene epoch, just a few million years after the impact, Earth had become a place that felt both familiar and completely new. Fast forward 50 million years, and placental mammals and the first true primates are already starting to make their debut. Fast forward a few more 100 million years, and humans stroll onto the scene, walking across the African plains. In a blink of an evolutionary eye, they'll rise to be the ultimate beneficiaries of the dinosaurs' demise, multiplying, advancing in intelligence, and eventually reaching such heights that they'll piece together the long-lost details of events that unfolded millions of years before they even existed. In the end, it's not just some ancient disaster tale, it's a big wake-up call about how fragile our planet is. Sure, we've come a long way since then, but when you look at what happened to the dinosaurs, it's hard not to feel the echoes of what could go wrong in our time. That asteroid came out of nowhere, obliterating nearly 75% of life. It was a disaster on a scale we can hardly imagine. Yet we're creating our own chaos, not from the sky, but with our own hands. So how worried should we be about another asteroid coming our way? Yes, it sounds like something straight out of a sci-fi movie, but it's real. Astronomers have been tracking near-Earth objects for years now, rocks that cross our path in space. Most of them are harmless, but we know from the past that all it takes is one big one to cause absolute mayhem. The one that hit Earth 66 million years ago was just 10 kilometers wide, a speck in the vastness of space, but it was powerful enough to end the dinosaurs' reign. The good news is that we are not completely defenseless. NASA's Planetary Defense Coordination Office and the DART mission are already on the case, with the tech to monitor and maybe even deflect any rogue asteroids heading our way. The Chicxulub asteroid didn't just wipe out life, it triggered a chain of environmental horrors, wildfires, acid rain, and a brutal global winter. But it sounds familiar, right? We're facing rising temperatures, stronger storms, and oceans that are becoming less and less hospitable. Climate change is like the asteroid impact, but with a human-made twist. What if the dinosaurs had faced not the asteroid, but a shifting climate over time? Would they have adapted, or would they have eventually gone extinct anyway? The truth is, no species is invincible, not even us. If we don't take a serious look at what we're doing to the planet, we might find ourselves in a very similar situation. And that's a scary thought. The story of the dinosaurs' extinction is not just a tale of destruction, but also one of renewal and adaptation. It is a testament to the enduring spirit of life on Earth and the endless possibilities that lie ahead.